everyone. For what values of x does our series converge absolutely conditionally? We're also going to find the interval of convergence. First, we need to use the ratio test and take the limit as n approaches infinity of absolute value of a sub n plus 1 divided by a sub n. Find our limit and then force it to be less than 1 for it to be absolutely convergent. By the way, this is on my Facebook page. If you want to look at it, you can save a photo if you want. So let's substitute everything in. We're going to get the limit as n approaches infinity of, and then everywhere there's an n, write in n plus 1. So n plus 1 times absolute value of x to the power of n plus 1. Divided by 4 to the power of n plus 1. Times n plus 1 squared plus 1 times what we're going to do is dividing by a sub n is the same as multiplying by the reciprocal. So it's going to be 4 to the power of n times n squared plus 1 divided by n times absolute value of x to the power of n. Now let's simplify all this. We have the limit as n approaches infinity. Let's group some things together. Let's group this together with this. So this is absolute value of x times absolute value of x divided by absolute value of x to the power of n. And then for our 4's, we have 4 to the power of n divided by 4 to the power of n times 4. And then we have, you multiply these two, so that's going to be times n plus 1 times n squared plus 1. And the denominator, we're going to get n times n squared plus 2n plus 1 plus 1. All right. Now, simplifying this, these two cancel and these two cancel. So I can move this out front of the limit. So I can write this as absolute value of x divided by 4 times the limit as n approaches infinity. And simplifying this will give you n cubed plus n squared plus n plus 1. Simplifying this equals 2 right here. So that's just going to be n cubed plus 2n squared plus 2n. Now looking at our highest degree, we have the same degree here. So as this number gets larger and larger, this is going to get closer and closer to 1. So basically 1 times absolute value of x divided by 4 is our limit. Now we're going to force this to be less than 1. So we have absolute value of x is less than 1. By definition of absolute value, that means not 1 but 4. By definition, that means x is less than 4 but greater than negative 4. Now what we need to do is, this means it's absolutely convergent for this, or this right here. So what we want to do is look at these endpoints to see if it actually can equal negative 4. Like, can we put equal signs here? If our negative 4 and 4 are convergent as well, if it applies. So let's look at x. Let's just check x equals 4. So if you substitute 4 into x here, what's going to happen is these two are going to cancel out. So we're going to get the sum n equals 1 to infinity of n divided by n squared plus 1. Now if we let this be a sub n and let b sub n equal 1 divided by n, we know that 1 divided by n is divergent. So if you compare these two, what's going to happen is you do this limit here. And basically what you're going to get is n squared divided by n squared plus 1. That limit's going to equal 1, which is greater than 0. So it means they either both converge or both diverge. Since our comparison of 1 divided by n is a divergent harmonic series, or you can look at this and say that 1 equals 1 here. If this is P, that means our series is also divergent here. That just means on our interval at 4, we can't close it. It's going to have to be an open interval here. So now let's try our -4 that we have. So let's check x equals -4. So that's going to be the sum. In this case, you're going to get negative, but the 4s will still, these will still cancel. So basically, you're going to get n equals 1 to infinity of -1 to the nth, because we have to pull that negative out. Times n divided by n squared plus 1. Now, it doesn't converge absolutely, but it does conditionally by the alternating series test, because this is positive. If we compare it to, let's just look at this part here, n divided by n plus 1 squared plus 1, that's less than n divided by n squared plus 1, because this denominator is larger than this one. So it is decreasing. And if you take the limit as n approaches infinity of n divided by n squared plus 1, that is going to equal 0, because the denominator is going to grow larger than the numerator. So it converges conditionally by the alternating series test. Therefore, we can kind of summarize this. At -4, we were okay. We could make it convergent. So the interval of convergence is at -4. Now, exactly at 4, it diverged, looking at the P series or the divergent harmonic series. So the series converges absolutely on the interval. So this is your interval of convergence. It converges absolutely when we just have -4 to 4. Remember, that's when we had an absolute value of x is less than 4. That was when it was absolutely. It just can't equal these. All right. And it converges conditionally at x equals -4, which is what we have here. This last part we did. And that's it. Thank you. Have a nice day. Bye-bye.